Here's some more extra practice for graphing polynomials. Here's our first question. X plus 1 times x minus 2. Two factors, and we can see this is a quadratic. So if you were going to expand this quadratic, the first term would be x squared, and then some terms, and then the last term would be minus 2. Remember, this is the y-intercept, and this will give you the family of the graph. So we're in the x squared family, which means the graph should go in this direction here. So we'll find the x-intercepts now. So we let our polynomial equal 0. So that means that x plus 1 times x minus 2 equals 0. And that means from this factor, x would equal minus 1. And this factor, x must equal 2. So these are your x-intercepts. So now we're ready to draw the graph. We mark our x-intercepts, minus 1 and 2. And the family is an x squared family. So we go down through the x-intercepts like that, x squared family. So it's an up graph and passing through the two x-intercepts. The y-intercept was minus 2, so that's that number there. Now, second example, we have a cubic polynomial. If we were going to expand this polynomial, x times x times x, our first term would be x cubed. So this will give you the family of x cubed. The x cubed graph looks basically like that. So it's down, up. If you were to expand the constant term, you'd have minus 1 times 3 times minus 4 to give you 12. So the last term of this polynomial would be 12. And that would be your y-intercept. If you want, you can fully expand this and check yourself. So we can find the x-intercept now. So from our polynomial, let px equal 0, which means that x minus 1, x plus 3, x minus 4 equals 0. So our x-intercepts would be 1, minus 3, and 4. So now we can draw the graph. Let's put in the x-intercepts. 1, 2, 3, 4. And then on the other side, minus 3. 1, 2, minus 3 here. And notice our family is an x cubed family. So we're starting down on this side, and we're going to finish up somewhere up here. So that means we're going to go up through your x-intercept, minus 3, go through the 1, and then go through 4 that way. Okay, and your y-intercept was 12. That's 12 up there. 1 there, you can't see it now. Okay, so that's your basic cubic graph with 3 x-intercepts. In this example, notice we have two factors here which are the same. If you like, we can write them out. X plus 2, x plus 2, x minus 3. Okay, so if we let px equal 0, this would be 0. So what would be our x-intercepts then? We'll get minus 2, and this one again minus 2. This is your repeated root. And this one would give you 3. Okay, so our family, if we expand out, notice this is x squared. X squared times x would be x cubed. And the constant term, notice here you've got 2 squared. So 2 squared is 4, and 4 times minus 3 is minus 12. You can expand again to check that yourself. So our family is an x cubed family, and our y-intercept will be minus 12. With our graph, we mark on the x-intercept, so minus 2 here, and then 3, 1, 2, 3. We have an x cubed family, so we're going to be coming from the top down to the bottom here. Okay, so what happens here, because you have a double root, so you've got x plus 2 all squared, this power is even, okay, which means you will bounce off the graph. If it's odd, it means it will cut the graph. So if this was 4 instead, it would still bounce, or 6 or 8 or 10. Okay, so because we have an even power for the factor, your line will bounce off the graph. So we'll come up, bounce off minus 2, go down through your x-intercept, which is minus 12, and then go up through 3. Okay, so just be aware of these roots where the graph bounces off. Okay, in the same way, the next square graph, an x squared graph will bounce off the axis as well, as minus x squared. Okay, so here's another one. Now we have two double roots. So for the first one, your x-intercept is going to be 1, 1, so double root, and this will be minus 2, minus 2. And if you were to expand this, you're going to get an x4 graph, a quartic graph. X squared, fully expanding, and multiply to this factor, x squared, you'll give x4. Your final term is minus 1 squared, 1, times 2 squared, 4. 1 times 4 is 4. Again, you can expand that to check yourself. So now we have an x4. And remember, x4 graph looks like this. It's similar to an x squared graph. So this is actually in the x squared family. So it's going to be up, up when we draw our graph. Let's try to draw the graph. We've got minus 2, and we've got 1 here. Okay, and because these powers are even, we're going to bounce off the graph at those points. And because it's an up-up graph, we're going to come down from the top. We bounce. You go up, and your y-intercept is 4. Here somewhere, that number. Then you'll come down through 1, then you'll bounce again, like that. Okay, so double root, minus 2, minus 2, you're going to cut through, you're going to bounce off the graph, and at 1, you're going to bounce off the graph as well. Okay, so that's a quartic graph, that one. Example 5. Now we have a triple root, so x minus 1, x minus 1, x minus 1, x plus 3. And let that equal 0, we can get our x-intercept. So x would equal 1 from this triple root and minus 3 from this root here. Now, because this is an odd number, odd power, we will cut the axis. It won't bounce, it will cut the axis at 1. So let's think about the graph. We mark our intercept, which is 1, and minus 3, and 2, 3, minus 3. Now our family, we've got an x cubed times an x, so x4. And x4 is in the x squared family. So it's up, up again, like that. So, and notice now we're going to cut both of these. So we'll come down, we'll cut. Oh, and Y-intercept is going to be -3. Okay, so come down like this, -3, and then it will go up like that. It will look something like a quadratic, but the graph is not perfectly smooth. So if you go to a website and graph this, you can see actually what they look like. So when you're doing your homework, you can actually go to desmos.com, DESMOS.com, and you can check the graphs in the computer, okay? Then you can actually check if you're doing it correctly.